Hello everyone. Welcome to the Eastern Shore Citizen Science Coastal Monitoring Network. In this space, we explore the keys to understanding, protecting, and managing our coasts in a resilient manner. This chapter is the 8th part of a 9-episode series dedicated to a fascinating topic, beach profiles. After taking our measurements with the profiler on the beach, what's next? Now we're going to learn how to process those numbers to turn them into a clear profile and understand what they tell us about our beach. First, we calculate the exact horizontal distance of each step. Then, we add up the height differences to find the elevation of each point. Sometimes, the dots are not perfectly spaced. If necessary, we can use a technique called interpolation to connect the dots and get a smoother profile. At the end, we will have a series of points that draw the profile of the beach. This is how we get the real shape of the beach. For starters, spreadsheets like Excel are perfect. They are easy to use and allow us to organize the data, make calculations, and view a simple profile chart. They can also be graphed in more advanced languages such as Python or R. The best way to see the results is a graph. We'll put the elevation of the beach on the vertical axis and the distance on the horizontal. This way we can clearly see the shape of the beach, its slopes, and whether it has berms or dunes. The most exciting thing is to overlay various profiles taken at different times. Thus, we can see how the beach has changed, if it has lost or gained sand. It is key to understanding its dynamics. With this data, we can even estimate how much sand the beach has and how it changes over time. And if we combine it with photos and tide data, we will have a very complete view. Your participation is essential to protect our coast. Thank you for joining us in this episode, and remember to check on the other parts of the series. This video was generated with AI and is part of the project Enhancing Climate Action of citizen scientists on the eastern shore of Nova Scotia to support multi-level risk governance, funded by the MEOPAR Knowledge Mobilization Fund.